Hi, now it's time to try figure out the properties using steam table and all the other information you learned from TV diagram in terms of determining what phase, what properties, what characteristic for each phase. All right, time to put all those tools together. If you haven't done the previous videos, please go back to do them because you need them for this video. Okay, so now the first scenario, question number A. This is water. They give us two things. What's the two given? By the way, you're always going to have two givens, right? So first given is the pressure, which is 200 kilopascal. And the next one is X, 0.6. Whenever we were given the quality X, which we know X is between 0 and 1, we know immediately this is a saturated liquid vapor mix. Okay, so we answered this problem phase. And 0.6 means 60% is saturated vapor, while 40% is going to be saturated liquid. Okay. Then how do we solve? We need to find temperature in this problem, right? We also needed to find out internal energy for this problem. How do we go about? So you are given two properties, pressure and equality. What steam table should we go to? Remember we said table A4 is saturated table. It's temperature, and table A5 is saturated table also, but it was given pressure. Is this saturated? Yes, because it's a saturated liquid vapor mix. It's not superheated, not compressed liquid. So from there, and we given the pressure, we know immediately we're going to go to table A5 to help us find a few things. From table A5, first thing we can find out, if it's a vapor mix, we know the T, it's going to be equal to saturated temperature, right? At 200 kilopascal. Because we know, refer to the previous video of the TV diagram further explained, at a saturated liquid vapor mixture, the temperature is going to be equal to saturated temperature, the boiling temperature. So we just need to go find that number there. Now let's go to do that though. So at table, and this is in SI unit, we're going to look at appendix table A4. I'm sorry, table A5, and we said the temperature is 200 kilopascal. At 200 kilopascal, so we are looking at right here, right? It's probably hard for you to see, and I'm going, so 200 kilopascal. So make sure you're doing the same thing. You are looking up the table with me at the same time. So 200 kilopascal, the saturated temperature is 120.21. 120.21. So we figure out the first problem, the temperature. Now we just need to figure out U. Since this is a mixture, we have a formula using quality, right, to describe the U. It is UF plus X UFG, also equal to UG minus UF. Then we can just go ahead and find from the same table A5, what's UF at 200 kilopascal. At 200 kilopascal, U is this value, 504.5. Our quality is given 0.6 and UG minus UF. So let's go to the table, which means the difference between UG and UF, and it's explained right here, this value, right? 2024.6. Okay, so knowing that, we can go ahead, try to calculate our U, and here I'm gonna get my calculator up right here. Oops. So putting the calculator, my answer here gives me 1719.26. And what will be the unit? The unit will be kilojoule per kilogram. That's going to be our specific internal energy. So we solved the question number A. Okay. Now let's go ahead and looking at another example, which is question number B. What is given here? The temperature is given 125 degrees, and also our U is 1600 kilojoule per kilogram. How do we solve this one? Again, have two properties. Want us to find the rest. We don't know what region. Don't predetermine or presume, oh, it's going to be a mixture. It's going to be compressed or liquid. You have to make that a priority. Figure out which phase first. So that's our mission. Which phase is this? How do we figure it out? You're given the temperature. We do not know what phase, but how about we go ahead and make that as our quest? T is given as 125. So knowing that, why don't we go to temperature table, which is table A4. Temperature table A4 is saturated, but that gives us some guideline. Okay, let's see how that goes. Because the second property is U. I'm going to find out the U to determine what phase this is, because we already know the criteria. If U is less than UF, we know it's what? Compressed liquid. If we know U is between UF and UG, we know that is a saturated mixture, liquid vapor mixture. If our U is even greater than UG, then we know it is superheated. So that's a quick review on one of the criteria. Again, check out the video on TV diagram further explained. So now let's take a look at this one. So we go to table A4, and we're going to use this given U to compare with UF and UG. Okay, so at table A4, what is going to be our UF? And what will be our UG at 125 degrees? Again, this is SI unit. We're going to look at table, we're going to look at A4. I forgot what temperature. 125. Okay, so at 125, this is 125 right here, and we're looking at U. It's this column, so this will be our UF, 524.83 kilojoule per kilogram. Ours is greater than that, right? That doesn't say too much. We have to compare it to UG. So go back to the same table. 125, look at the UG. Our UG is 2534.3. Okay. So now we can compare our U. Our given U is 1600. And we realize something very interesting. Our U is in between UF and UG. based on our criteria discussed just now, that is a mixture. That is a saturated liquid vapor mixture. So we figure out the phase, right? We didn't know before until we just did this step. So that's educated, not a guess anymore. It's like a verification, exploration, or whatever you call. So this is going to be our saturated liquid vapor mix. Now let's go back. What do we need to find out? We figure out the phase now. We just need to figure out quality and pressure. So we need to find out X and our pressure. Again, if this is a mixture, we know during this process, saturated liquid vapor mix, when you continue adding heat to it, what happened? The temperature stayed the same, the pressure stays the same, right? When you boil the pot of water, the temperature stays at 100 degrees Celsius and the pressure stays at 1 atmosphere pressure. So in that situation, when you're trying to find a P, that P is going to be saturated pressure at this particular temperature at 125 degrees Celsius. Again, that's going to be from our table A4 because temperature is given. So go back to the same table, 125, and the first column, this column, that's going to be our saturated pressure, 232.23. That's going to be our kilopascal. That's our saturated pressure. Okay. Then the next question we were solving is quality. Yes, there's a quality associated to this problem because it's a saturated liquid vapor mixture. How do we find that quality? We know the second property is U, right? Internal energy. U has a formula at saturated liquid vapor mixture is equal to UF plus X plus times UG minus UF. And here we know the U already. We want to find the X. So just using the math. So X is going to be just equal to U minus UF divided by UG minus UF. Let's go ahead and put our numbers in. Our given U, which is in between UF and UG, is 1600 minus UF, you got from the table, 524.83. And our UG minus UF, you can either use those two numbers to subtract each other, or you can just go ahead and find from the table. They are given UFG already, 2009.5. Right? Then we can find our quality. So our quality right here is 0.535. That's our quality. Okay. So what does the number mean? Which means 53.5% of mass, it is saturated vapor. And the remaining one, 46.5, that's going to be our saturated liquid. All right, so that is the two examples. We use steam table to solve those unknown. They all share the same